On the 10th of July at ESA's Space Operations Center in Darmstadt, Germany, the tension was mounting. In the control room, scientists awaited a unique event taking place 450 million kilometers away. The rendezvous between Rosetta and Lutetia. Rosetta, the ESA spacecraft, would pass only 3,000 kilometers away from Lutetia, an asteroid circling in the main asteroid belt between Mars and Jupiter. And then the first pictures started to come.
We discovered tonight a new world. It's the largest asteroid ever seen by a human, and it's really, really exciting.
Launched by an Ariane 5 in March 2004, the aim of Rosetta and its little 100-kilo landing craft is to study a comet more than 600 million kilometers from Earth, a meeting planned for 2014. But along the way, Rosetta has been flying by other space rocks, allowing for further scientific observation. Lutetia is particularly interesting as it's the first metallic asteroid ever to be visited by a spacecraft. 130 kilometers at its largest, Lutetia displays a fascinating landscape, a battered world of many craters, boulders, and mysterious grooves. Lutetia is probably a primitive survivor from the birth of the solar system.
We saw really great craters of 70 kilometers size. They are like a bowl. They are so large, so huge, and they are covered. So most of them, of the larger craters, they have a very round rim. So they are very, very old craters. So it's, it's discovery. So we have a lot of large craters, tons of old craters, small, and tons of small craters, even small craters in the large craters. So it's a lot of topography, a lot of excitement we don't understand right now, and it will keep us busy for months and years working these images.
But the main objective of Rosetta's 10-year journey is to meet the comet Churyumov-Gerasimenko and place a lander on it. However, with only small motors for steering, to arrive on time at its 2014 rendezvous, Rosetta needs some help. The flight engineers at ESA in Darmstadt use the gravitational sling effect from planets like Mars or the Earth to accelerate the probe as it orbits them.
But when you want to rendezvous with a comet, you have to accelerate the spacecraft and match the same velocity that the comet has around the Sun. So this is the problem, not only the distance, but also the velocity. You fly close to a planet, and you use the gravitational attraction of the planet to actually accelerate your spacecraft.
Once close to the 4-kilometer-long Churyumov-Gerasimenko, Rosetta will circle the comet. This maneuver is complex because the gravity of the comet is only a millionth of that of the Earth. The lander will then be launched.
Landing means flying very, very slowly over the comet and then gently pushing away the lander. It's not a landing like you can imagine on the moon, where you come with rockets and you have to brake. Here the problem is the opposite. You have to really touch gently the comet. The forces involved are very small.
The probe will remain in orbit while the landing craft is on the comet's surface, and this will happen while Churyumov-Gerasimenko will be approaching the Sun and therefore becoming active. Extreme heat will cause the comet's gases and water to evaporate, building up an atmosphere which appears as an aura. This gives the appearance comets are well known for, a ball with a tail known as a comma streaming out behind it. Eventually, both Rosetta and the lander will be put out of action by the dust emitted from the comet as it passes the Sun. Then they'll both stop working. But hopefully the long journey will pay off by then, since comets are in fact key to understanding our origins.
Comets are bodies in our solar system that have been left over ever since the solar system formed, some 4.5 billion years ago. And therefore, when we look into comets, we look into the past of our solar system. And so by investigating the details of comets, how they formed, how they evolved, we can actually have a glimpse into how our solar system formed, and in the end, how the Earth formed and why we are here.
So Rosetta is on its way to its final rendezvous with Churyumov-Gerasimenko. But studying Lutetia during this flyby marks the attainment of one of Rosetta's main scientific objectives, providing us with invaluable information about the universe we live in along the way.